In this video, we are going to go over the functional group esters. Esters are prepared from carboxylic acids. They are a carboxylic acid derivative. They are characterized by a carbonyl group in which the carbon atom has bonded to an OR group and to an R group. So the carbonyl carbon is bonded to an R group, so a carbon bond, and an oxygen bonded to a carbon bond. The condensed structure is RCOOR or RCO2R. An ester resembles a carboxylic acid, except instead of a hydroxyl group, so an OH group, it has an OR group right here. So a carboxylic acid looks like this. So this is a carboxylic acid. So the difference between a carboxylic acid and an ester is this R group. Many esters are fragrant and pleasant smelling. So these are examples of some esters. We have methyl ethanoate or methyl acetate. We have a methyl group as an R group off the carbonyl carbon, and then an oxygen bonded to a methyl group off of the other side of the carbonyl carbon. Methyl propanoate, we have an ethyl group off of the carbonyl carbon, and then a methyl bonded to an oxygen off the other side of the carbonyl carbon, and then ethyl propanoate. Esters versus ethers. So the carbonyl group and the OR together constitute the ester functional group, and they act as one unit in a chemical reaction. Esters and ethers have different chemical and physical properties. So comparing carboxylic acids, esters, and ethers, we have a carboxylic acid, and the carbonyl carbon, oxygen bonded to hydrogen. We already said that ester is very similar to a carboxylic acid. The oxygen bonded to the carbonyl carbon is bonded to an R group or a carbon instead of that hydrogen. And the ether is an oxygen singly bonded to a carbon and another carbon. The carbon on the left side over here is not a carbonyl carbon. It is not bonded to it's not doubly bonded to an oxygen. Physical properties of esters. Esters have permanent dipoles and form dipole-dipole forces. They have no hydrogen bonding because there's no hydrogens off there. If there are a lot of carbon atoms within the ester, then they're mostly nonpolar and hydrophobic. And esters have higher boiling points than alkanes of similar size or ethers, because they have stronger dipole-dipole forces, but they have lower boiling points than similar alcohols or carboxylic acids because they have no hydrogen bonding. So if we look at the spectrum of alkanes, ethers, esters, alcohols, and carboxylic acids, alkanes have the lowest boiling point, ethers have the next lowest boiling point, esters are in the middle, and then alcohols and carboxylic acids have boiling points higher than esters because they are capable of those hydrogen bondings. Esters in nature and pharmaceuticals. Esters have flavor and fragrances of many fruits and flowers. Esters are widely distributed in nature, and reactions of esters are very common in biochemistry, especially fat molecules. So fat molecules have 3 ester groups on adjacent carbons. So this is a fat molecule. We have 1, 2, 3, and these are all carbons. So on 3 adjacent carbons, so 3 carbons next to each other, in a 3-carbon chain, the R groups of esters are long hydrocarbon chains that may contain double bonds. So these are the R groups, and they are hydrocarbon chains. Aspirin contains an ester, carboxylic acid, and aromatic ring. And procaine and benzocaine are topical anesthetics, where ester is necessary for their properties as topical anesthetics. So they have other functional groups within, so procaine and benzocaine have other functional groups within their structure, but the ester is necessary for their properties in order to work as topical anesthetics. So in summary, esters contain a carbonyl group with bonds to an R group and an oxygen bonded to an R group, oxygen singly bonded to an R group. The condensed notation for an ester is RCO2R or RCOOR. Esters have a permanent dipole and therefore dipole-dipole intermolecular forces. Esters have higher boiling points and greater solubility in water than alkanes and ethers, but lower boiling points and solubility than alcohols and carboxylic acids. The more carbons you have in an ester, the less soluble it will be in water, and the more nonpolar it will be. Fats are biomolecules characterized by 3 ester functional